In this video, I will summarize the mathematical models or formulas describing an object's motion. The mathematical model for the position of an object is generally given by the equation of a parabola, y equals ax squared plus bx plus c. We can rewrite this as x of t, or position as a function of time, equals 1/2 of the acceleration times time squared plus the initial velocity times time plus the initial position. If any one of these terms is missing, that would mean that the acceleration would be 0, or the initial velocity would be 0, or the initial position would be 0. Here we have some examples. In equation number 1, we have all three terms. So the acceleration described by this motion is double the t-squared coefficient. That would be 11.4 meters per second per second. The initial velocity is the t coefficient. It would be negative 3.6 meters per second. The initial position is this constant term, which would be 10.1. In equation 2, we don't have the middle term, the t term, so that says that the initial velocity is 0. Our acceleration is negative 17 meters per second, and the starting point is the negative 7.7 meter mark. In example 3, there is no constant term, which means the initial position was 0, the origin. The initial velocity is negative 3.8 meters per second. The acceleration is 10.4 meters per second. In equation 4, there is no t-squared term, which means this is the equation of a line, and linear position graphs are constant velocities, which means no acceleration. Because there's no t-squared term, it's in fact 0 t-squared, so the acceleration is 0. The initial velocity is the final velocity, is the average velocity, is the constant velocity of negative 7.9 meters per second, starting at the positive 3.7 meter mark. Example number 5 has no t-squared term, so the acceleration is 0. There's no t term, so the initial velocity is 0, but the position is 15 meters. This is the equation of an object that is at rest at the 15 meter mark. Example number 6 is another example of a line. There is no acceleration because there's no t-squared term. The initial velocity is 8.5 meters per second, and the starting point is the origin, 0. So numbers 4, 5, and 6 all depict objects that are moving with a constant velocity, no acceleration. These are linear graphs. 1, 2, and 3 have acceleration. The objects are changing the velocities. Those are parabolas. The graphs curve. Now, if we do a mathematical model for our velocity, because we're dealing with constant acceleration, all of our velocity graphs will be linear. They will be lines that either slope upward, downward, or are horizontal. The slope of the line will be the acceleration of the object. So our velocity equation, velocity at any time t equals the initial velocity plus the acceleration times time, or we can reverse the order that those are written and make it slope, acceleration times time, plus the y-intercept, initial velocity. If there is no t term, then our velocity at any time is the initial velocity. That's a constant velocity, no acceleration. If there's no constant term, then that means the initial velocity was 0, so the object started from rest. Notice that this equation does not in any way give us any information about the location of the object. We cannot get an initial position or position at any time from this equation. So here are 4 examples. Example number 1, the velocity at any time t is 3.8 times the time. there is no initial velocity or no constant term, so we started with an initial velocity of 0 and have an acceleration of 3.8 meters per second per second. In example 2, we have an initial velocity of negative 3.8 meters per second. The acceleration is 5.2 meters per second per second. Example 3, there is no t term, so the a acceleration would be 0, and we have a constant velocity of negative 7.3 meters per second. So that initial velocity is its constant velocity because it's not changing. Example 4 is the equation of an object that is at rest. Its initial velocity is 0 and it has no acceleration, which means it's not changing its velocity. So if you start with a velocity of 0 and you don't change it, that means you remain with a velocity of 0, so you are at rest.